It's going to be a very simple introduction. It's just to give you a little taste of what Lua can be, and introducing, as it says there, the script editor, which is our tool that's been a part of Nspire now for just 12 months. We'll see how to use this tool to create dynamic environments, which we can use in our teaching of math and science. I'll point you in a moment to some scripting resources, and as part of this webinar series, you'll find out ways to stay in touch. So we're looking forward to working with you guys this evening, and hopefully you'll find it useful.
Thanks, Steve. Marc, whenever you're ready, go ahead and share your desktop.
Okay, and let me know if my audio is coming in from a different phone.
Yeah, I just heard it cut out once or twice there, so we'll see how it goes. As Marc is now sharing his desktop, that right section of your screen with the chat or the Q&A windows has been replaced with that green floating toolbar. So as Marc or Steve is discussing things tonight and showing things, if you have a question or you want to see something again, please feel free to use that chat or the Q&A window if you have a question, and we'll try and get your questions answered live. Marc, it's all yours.
Okay, thank you, Mike. There will be a couple of documents that will be made available to you after the webinar. One of them is just a very quick overview of some of the reasons why, for me anyway, it's really worthwhile doing Lua. So without going into any of these specifics, I'd rather show you how it looks live with some very quick examples. It's created for the middle school math-inspired set of activities. And this is a document that I think I spent over 24 hours in total trying to develop and get it to work entirely within the Nspire platform. So as a result, there is so much going on in the background just to make it work and fun. So right off the bat, it's not very quick on the handheld to grab these. Okay, see, I still have audio issues, but I will try to continue. To grab these blocks requires grabbing points. To rotate these blocks requires grabbing a different point, and it becomes a bit of a nightmare for user interface. So instead, what this looks like in Lua it is a much anywhere on a block to move it into place. To rotate is very simple with a click, and just the overall speed as well. It's so much quicker to load and run and use. And I apologize as it looks like I may still be having some audio issues. This next one shows a different idea about what Lua can do. One of the things, or something that we certainly cannot do in just native Nspire, and that is to create animations. So this was an animation that was done for a particular, it's one of the smarter balance questions that was converted for Nspire. So I'll just play enter and let you watch and see. So it's just a very simple animation, but you get the idea of what can be done once we have this script language within which to create things. One of the most exciting, and I'd say the best for last, one of the most exciting aspects of using Lua is a physics engine that lies underneath and can be used. And you might have seen this kind of document already. This one is the energy skate park. And it's just amazing to think about what sort of thing this can do. So I will take this opportunity now to pass it back over to Steve, and he is going to show you some of the resources that are available for finding out more about how to get this far with learning on using Lua.
Steve, I'm not sure, I'm not getting any audio on your end right now as well.
It'll help if I turn mute off. Hey.
Yes, it does.
Thank you. Sorry about that.
Good.
We're getting our act together here. Look, one of the best places to start for Lua is the set of tutorials that I've made available on my website. Tonight we'll just give you a very brief introduction and a taste, hopefully a tempter. And if it's something that you would like to go further with, or if there are any parts of what we do tonight that you'd like to explore more deeply, then this is the go-to place. We'll send you the address shortly. Once you come to my website, if you click on the TI-Nspire icon, you'll be taken into TI-Nspire world. A lot of resources about the platform. If you scroll down a little bit past the images, you'll see a link to TI-Nspire Lua Scripting HQ. And this was set up by me over the last 12 months or so as I've taught myself Lua. I'm not a programmer, so I wanted to see whether it was possible for a non-programmer to be able to get into this exciting world. And I was surprised that I found it was much more accessible than I had believed. So I started to document my learning process, and these turned into what now amount to 28 lessons. So lesson 1 from first steps. And these assume that you know nothing about Lua and that you don't have, they assume a non-programming background. So if it's something that you're interested in, don't feel that it's you need to be an expert to get into it. And it takes you from very, very simple first steps right through to the physics engine that Marc talked about. And most recently, we've welcomed the iPad, so scripting for the iPad. On this page, you'll also find a bunch of resources of Lua documents that give you some taste of the breadth and variety of the platform and what becomes possible in this world. So tonight, a very, very simple introduction, and the document that you'll receive and you can work through at your leisure, my first Lua script. The title page, hopefully you're seeing text being moved around as I drag the mouse. That's basically what you're going to learn how to do tonight. To get into the script editor from version 3.2 of the software, and it doesn't matter whether you're on student software, teacher software, or even navigator software, the script editor is there. The only place you can't access the script editor is from the handheld, which makes this, that's intentional. It's a secure environment, so you can develop as teacher, develop your documents, send them out for students to use, and know that they can't get in and break them, either intentionally or otherwise. So what I'm going to do, and I suggest when you're trying this out yourself, perhaps afterwards or while you watch the video, there's a couple of ways to make this work a little better. In the window menu of Inspire, you can auto-hide the Documents toolbox on the side, giving you more real estate. And generally what we're finding we tend to do these days is to bring the Inspire window down to about half size, take up half your screen. To access the script editor, we go to one of the insert menus. There's one up in the top level, and there's also one in this menu bar. Down the very bottom of the insert menu, you'll find script editor. If there is a script on that page, then you'll be able to access this item, edit script. When you choose that, it opens the script editor, and you're looking at the script that defines that page. Now, I've also resized the script editor to be half the window, as you can see. And I'm not going to go into detail of all of this right now. We're going to build this up step by step, but you'll see that in about 45 lines, we've created the ability to do this. So the first activity is very, very simple. I'm going to hand back to Marc, and he'll get you started.
Okay, I believe my audio issues will now be much better. I'm going to continue under the assumption that the audio is now working well, and again, I apologize for the stuff that you missed, but now that I'm here for the main stuff as we get to the meat of working on a script and putting something together. We're going to start off very simply with just how do we place some text on a page. So once you have, as Steve showed, opened up the script editor, which reveals to a page, and here's the result of this script. All we're doing very simply on this, everything in Lua is built within functions that have a starting and end point, and we will unfold some more functions as we go along. The on-button is the one that actually paints things to the screen that is seen. So within that, or in references to that program, that's where everything that is visualized as seen comes into play, whether it be text, graphics, images, other elements that can interact and play within the visible screen. Created a string just called page, as this will be for many of you the first Lua page that you have been building. And so as you can see, as I can change that text and save the script, it gets automatically updated on the screen. So that is the actual string. The command that we use to draw the string is very simply draw string. The first item is referring to the string itself, and then the next two numbers are its orientation on the screen. So you can see right now it's set to 0 and 20, and that places it horizontally at 0, which is right on the very far left, and vertically at 20, which is just down a little bit from the top. One of the things that you need to get used to, we are, as math and science people, we're used to numbers up as you go up in a vertical direction, but with the Lua page, we need to think in an opposite way. 0 is at the top, and then it moves down. Just to give you a sense of the size of the screen when we are in handheld mode, if I bump up the X value to 100, you'll see how far along it goes. And that is for the beginning part of the string there. And so you see it's about a third of the way across the page. And so in total on a handheld screen, we have a little over 300 pixels in width. And vertically, I'll just bump this up. I'll do this as well as 100 as well. And you know, it goes vertically a little under half, so over 200 in a vertical direction. And as you get going more with this, you can learn more about how to place things. But as long as we rely on trying to figure out values for that, it's going to become rather arduous. And so what we're going to get into as we go along here are some better ways of figuring out where to place things on the screen. And so it isn't just a guess and check about how to get something to appear in the middle. It's actually something we can control using some mathematics. So I'm going to pass it now back over to Steve to show you that next step.
Thanks, Mark. Share my desktop. Have a look at problem 2. This is broken into problems, and this is what we're looking at. Now, straight away we see that the appearance is quite different. We have a lot more control over things like text size, colour, style, than we do in native Nspire. The script has been changed by adding a few extra things. Let's have a look at this. What we have within Lua is the ability to measure at any time the platform window width and platform window height. So we assign them to variables W and H, and then we have an idea of how big that is at any time. I'll just point out, if I switch between handheld view and computer view, let's change the position as Mark did. If we put it at 100, 100, I set my script. On computer view, that puts it there. In handheld view, it puts it there. And part of what we've had to learn is if we want to write scripts that are going to work not just on the handheld, but on the iPad and on the computer, we can't use absolute values like these. We need to use relative values that measure the size of the window at any time. So if W is the window width and H is the height, then we might expect that something like W over 2, H over 2, might have the desired effect. So that's telling it to draw the string, the middle of the width, the middle of the height. Let's see what happens. Not quite what we were after, but it does have the effect of, it doesn't matter which view we use, it's adjusting automatically. That's a good thing, so we've just got to work this out. The position defined by those X and Y coordinates is the top left corner of the string. So clearly what we need to take account is how long is this string? And again, we can do that within Lua because we've got a nice little command called getStringWidth and getStringHeight. We'll call them SW and SH, and then clearly we can do something like this. Now, if I was to bring it back half the string width and bring it up half the string height, H over 2, and theoretically, that should put it right in the middle. Now, to be honest, I don't use string height all that much. I use the middle command, which automatically sets it for the middle of the text. The other versions of this are that I could use one called top, and that aligns the top of the text with the position that you defined, and there's also bottom. But if we do middle, it pretty much takes account of this, and so in future I'm not going to worry about string height. I'm going to use this. I'm going to say get the width right, and the height we'll set in the middle, and that should pretty much take care of where we want it to be. The other things that we offer on this page are some nice features. This is italic. Let's make it bold. Let's make it regular. Let's even make it bold italic. There's only 4 choices. It's a simple world. Clearly we have 14. This is setting the font, so we can change the font size, make it 24. You can go up from there. And the other option we have here, there are 2 font styles. Serif, as we have at the moment, which shows the little hooks and nice touches on the front, or sans serif, which takes those out and gives you this blockish appearance. Now, that's actually preferable a lot of the time for a small print to make it more readable. So these are choices we make. And finally, the other thing we've added here, so we can set the font style, size, and font. We can also set the colour. RGB, red, green, blue. Numbers between 0 and 255. So if I was to set the first number as 255 and the other 2 as 0, RGB means that that's going to be pure red. If I was to fiddle around with points in between, then we're going to get all sorts of interesting effects. This one's going to be strongly red, but with a fair amount of green and a little bit of blue. Skips that. Sometimes they're surprising. So this is a lovely thing to play with. We have thousands of colours. So that's our, we're starting to see the power of this in terms of our control over the strings and the text that we can use for our students' documents. I'm going to hand back to Marc now for the next step in our little Lua journey.
And Steve, while you're doing that, I think Kim just asked a question. She was trying to type the exact same thing that you were typing into her script editor, yet she wasn't seeing anything.
I was having some of the same effect, which was interesting. You do have to be careful that focus is on the editor. You've got, you need to click with your mouse to make sure that your cursor is actually working within the editor, because otherwise you can click across and it'll be on the Nspire page. Yeah, generally there's no problem typing into the editor. So if you continue to have problems, that's something we might want to follow up later on.
Yeah, and another thing is just to make sure you actually set the script, which is with a Control S or a Command S if you're using a Mac, so that once you make changes for it to appear, for the script to actually start running, you need to actually set the script with Control S or Command S. So moving along, one of the things that happens as you start to develop in a language or in a scripting language like Lua is starting to learn about ways of making the code run a little bit more efficiently, and there's just this opens up a whole big area of things that we could get into. So we'll just do a little bit right now and looking at something that Steve started with you, and we'll just add a little bit more to it to make the script run a little bit better. So I'm going to go to edit the script. And so some of the things that we have here, we won't get into a big discussion about using local variables versus global ones. It does help things run better if variables are defined locally. In this case, a lot of the things that Steve had defined later, we can bring outside of that onPaint function, and by doing that, it becomes available to other functions that we might define. As you see, we'll be able to start adding more and more controls and other things with other functions. And so things like the screen height and width are things that we want accessible to many of these other functions. A particular function that also shows up here is on resize. And this is an important function to include. Basically what it means is that if the screen changes size, then it'll restart the script. Now this may happen obviously if you're using computer view and you change your window size, you want everything on the screen to be able to adjust accordingly, which is a really nice feature. It might also happen on the handheld if you switch to split screen. Then all of a sudden that part of the window adjusts in size. Maybe I'll just do a quick demonstration of that. Notice that even though I just split the screen, the script automatically put it back into the middle because now it's defining it for that smaller window. It redefines the screen width and height. This also allows it to be flexible to whether a script is running on a handheld, on an iPad, using software with varying different sizes. This really gives us a lot of power to make the experience common for all different users. One of the biggest frustrations and difficulties I've had trying to create things on Nspire is the fact that it can look very different on computer view and handheld view, and this gives us the ability to be able to be a lot more universal no matter what the platform is. So I think that covers this page. I'm going to pass it over to Steve to introduce some new functions and some exciting abilities.
Okay, while I'm sharing my desktop, there was a question that came through. What are those colons doing? And there's elements of this that that if you're a non-programmer are going to take a little bit of getting used to. But very briefly, I've defined a variable called screen, so I don't have to type platform.window every time, and it helps me to it reminds me what it's talking about. So now instead of saying W equals platform.window width, I can just say screen width and refer to screen throughout this. So you see the colon here is saying that's a property of the screen. I'll mention a couple of other things while we're going. We're going down in the paint function. We've glossed over this. There's a thing called GC. And within your paint function, when you want to paint something to the screen, it defines what's called the graphic context. Now, this is technical stuff, and I'm not going to try and explain it because I probably don't fully understand it myself. But when we're using graphics commands like set font, set color, and draw screen, they need to be done within a certain graphic context, and that's what the GC refers to. So the simple way is, whether you really understand it or not, include it and it works, leave it out and it doesn't. So I tend to include it. What we're going to add in this particular page is a bit of fun. And what I'm doing at the moment on the page is I'm just clicking in different places with the mouse, and you'll see that it's making the text jump around. Everything's the same as what Marc just had. I've added 4 new lines, 5 new lines. I've added a function called onMouseUp. So I'm getting a mouse up signal from the page. It picks up the coordinates of where you click the mouse. It then assigns start X to that X value, start Y to Y, and will make the string then, when it draws, jump to that position, which is pretty cool. This one here, this line that says screen invalidate, possibly a better word would have been refresh, because that's what it does. The onPaint command is constantly drawing, it's constantly refreshing, it's constantly being refreshed and repainting the screen every time it's called. If you define another command, like mouse up, you need to tell it to refresh the screen. So any function you put in that affects the appearance should have a screen invalidate, or its full title, platform.window invalidate. And that will say, one of the things it's got to do when the mouse comes up is to refresh the screen. And that way, now this is not so important on the computer. You'll find if I leave this line out, and I can actually comment a line out by putting 2 dashes in front of it, what you'll find on the computer is it'll still work just fine. This is because the way a computer works is that it's constantly checking for signals of change. The handheld, though, is a much simpler system, and if you left that command out on the handheld, you'd be clicking away and you wouldn't be seeing any changes because it's not being told to refresh the screen. Another question from about order, and thanks, Adrienne, for answering that. The order you basically put these commands in, these functions, is not important. It reads through the whole thing, and then it does them in the order that it's told to. And so in this case, it's taken all of this in, defined all these variables, understood this, and then the main thing it's been told to do is now paint the screen. So I could have put this after. I'll set the script, and it will still behave exactly the same. So small things like that. I tend to put the paint command at the end generally, but it's a question of your own taste. And real programmers have a lot more protocols and things that I don't understand, so I'm not getting into that. But this it gives you a little taste of the power of this, how quickly and easily we can do something like this. I'll mention the 2 other mouse commands. There are 3. Mouse up, mouse down. Now, if I make that a mouse down, it's not going to make any difference, okay? Because all it's doing now is that as I press my mouse down, it's carrying that out. But since I generally put the mouse down and then up again, that's not going to work much different. Although if I did change this back to mouse up, and I click and hold the mouse down, I'm holding it down at the moment, you'll see it's not carrying this out until I release the mouse. So that's the main difference there. Generally with mouse down, suppose I've got a button. Then what I'll do is put some commands on mouse down, so maybe to change the color or make the button look different so you can tell when it's depressed. And then have the actual commands that the button does happen when you let the mouse up. So that gives you some control. But the fun one is mouse move. So we have mouse down, mouse up, and mouse move. Have a think about what this is going to do, and it's pretty simple. As you move the mouse around, it's going to take the text with it. Now this can apply to text, it can apply to any sort of object that you use on the page. And I'm going to hand back to Marc now to go the next step on. Let me just do that. Because we've seen what you can do with text, and that's pretty cool. But Lua is a graphic environment at heart. So let's see how easily we can introduce some graphic elements as well.
And Marc, before you jump in, I think I've noticed a couple people in the chat window. You have some options whenever you chat, and chances are you probably want your chat to be seen by everyone, including both Steve and Marc, so in case there's a question in the chat window, they can see it. And the best way to do that is whenever you're sending a chat, send it to all participants. And whenever you do that, that will actually reach everyone, including myself, Marc, Steve, and everyone attending. So all participants is what you're looking for. Thanks, Marc.
Yes, so I noticed that there were a lot of answers coming in, but I didn't realize they weren't going to all participants from others. So just make sure, and we might have to go back and see if there are any unanswered questions. I know that there was one I just caught my eye in terms of the mouse actions. And although right now we are just introducing a single mouse action at a time, you can imagine combining all three of these possibilities so that when you put your mouse down somewhere, it can do something, and then a mouse move, and then a mouse up. So that whole idea of being able to grab an object, you create that mouse down event. Then as you start to move the mouse, then you keep your mouse down, and this is whether it's on a computer or a handheld, and it'll keep that action until the mouse. And so sometimes a lot of things end up having those three things working together. On to shapes, and this is where we can start making our the look of things give us a lot more options. The shapes are rather basic, and it's by putting these things together that we are able to start making things be much more visually pleasing. We're not going to get really excited right now. We will work with a rectangle, but we can also we can draw arcs of any angle of an arc, and we can also fill arcs. So that's how we can do or parts of circles. We can do rectangles, and we can also do polygons and lines as well. So those are the different kinds of shapes that we can create in this Lua environment. And so just to get an idea of what it looks like, everything on this script is the same as what Steve had, except for this one line down near the bottom. And it's a draw rect command, which is for draw rectangle. It is important that everything is done with the right case. So this is a lowercase draw and then a capital R for rect. It is case sensitive, so if I used a lowercase r, we would get an error. And what this is doing is we've defined start x and start y according to the mouse up command. So as soon as I mouse up somewhere, that will define my start x and start y, and that's how the rectangle moves into place. The next two parameters are the dimensions. And rather than trying to give them absolute values, it's much better to control these kinds of things using reference to the screen size. And so rather than giving the rectangle a particular width, it's set at 4/10 of the screen width, as well, and the height as well at 4/10 of the screen height. So just to give a couple of examples of some different things that we can do with this. One is I can change draw rect to fill rect and set my script. And now instead of drawing a rectangle, it is actually filling it. Notice this set pen command. That is something that also comes into play when working with graphic elements. So right now the pen is set to a thin line with that is smooth. If I wanted to add a border to this rectangle, then I can do a couple of things. I'm just going to copy this code, and actually I'll copy all three lines and paste it below. And let's give it, it'll have the same dimensions, but let's give it a little bit of the dirt. Let's maybe do something like that. And we'll change it to thick, and I'll change this one back to draw rect. So when I set this script, notice that it is now placed a very dark looking. Let's make this a little bit more interesting. There we go. The pen got set to thick, so it's a thick border. Instead of smooth, I can choose, my memory is failing me in terms of what the options are. I don't think it's dotted. Yes, it is one. And I think dashed is another. Yes, it is. So we have the ability to change some of the attributes within the code. In terms of order, one of the things to pay attention to is Once a set pen command is in place, it applies to everything below that within that paint function until I use a new set pen command. And that's why the set pen up above would have been in effect until we used a new set pen command. I'm just going to do one more little thing just to give you an idea of some of the fun you can have. This is geeky math programming kind of fun. I'm just going to change the color to depend on X and Y instead. So let's say here, instead of the color being 20, I will make that controlled by the start X value. And I'm just going to multiply it by 0.7 because of the range of numbers that we can use for the color spectrum. And let's change this middle one to start Y. I'll just keep it at start Y. And I'll just set this one down to 0. The other thing I'm going to do is change this to a mouse move so that we can see the color changing a little bit more dynamically. Okay, so now the rectangle is based upon my position on the screen, and it's set to change the start X and start Y values. I change the position of my mouse. So as you can see, how the colors can change as I move along the screen. Not that you would ever do this in a way, but it gives you some idea of some of the acts that you have a lot of power to do things based upon where the cursor is on the screen. You can control lots of different elements. This is just using color to do it, but you can control shape. You can change all sorts of different attributes of objects, appear, disappear, just simply by the position of the cursor on the screen. And with that, I am going to pass it back to Steve. Steve, you might need to unmute. You're still muted, Steve.
Unmute. Right. Sorry. I don't know how that happened. Am I back? Hello?
You sound good?
Yes,
Sound
yes,
good to me?
yes, you're back, Steve.
All right. Just quickly, I mentioned that as well as draw rect, we have several graphing commands: draw line, draw poly line, draw arc. All of these extras are covered in the tutorials, so this is just a little taster. What I'd like to just point you to in the last couple of minutes, we won't have time to unpack this fully, but look, here's a document where the top half of the screen is a little window, the bottom half of the screen is a normal graph window. I put in a point, called up its coordinates, and stored the variables as px and py. So down here, if I move it around, we see that as you can on the normal graph screen, you can keep track of the coordinates, but this Lua window is also doing the same thing. A really powerful feature of Lua is that in Nspire, it can reach across into the Nspire world and pick up information from there, and that's what's being done here. It uses a command called var.recall, and it recalls a current variable, if it exists, called px, and it brings it across into Lua world, gives it another name or the same name, and I can then refer to that. So this allows us to do all sorts of powerful things. In this one here, much the same thing is happening, except it's a two-way street. It's grabbing the current value of this point and it's storing it back so that what I'm using here, if I if I'm in my Lua window and I press left and right, up and down arrows, I'm actually controlling that point. Now you can't see the arrows. You'll see in the script here there's an arrow key command. If key equals left, then do this, and so on. Now I found this is a really powerful feature for the handheld. So what this means is if you've put a Lua script that has arrow commands on it, student comes to this page, and instead of having to go down and grab the point with their mouse, they still can do that. If they just immediately start using their left and right arrows, up and down arrows, they're controlling it as if they were grabbing it with their mouse, which is much quicker and easier. So, look, this has just been a very quick sampler of some of the possibilities, and there's so much more. In the time we had, I'm sorry if it's left you wanting and you think, well, if that's all it does, I'm not really impressed. I can't see how to use that in my class. Then I'd suggest that you take a bit of time and visit a website and have a look at Lua scripts that are out there, because this is just the tip of the iceberg. It adds so much functionality to our platform and lets you start to create, like I dreamed for years as a teacher, the things I wanted to be able to do with my kids. This gives me a way to achieve many